Okay, so on notes 2-3, we're going to be using logs to solve exponential equations. So remember on 2-2 we talked about there are going to be 3 different types of equations that we're going to look at this unit. Some that have all logs, some logs, and the third one where it was no logs. Okay, this is what we're going to be looking at today. Okay, so it's an exponential equation. There's not going to be any logs, but we're going to have to use logs in order to solve that exponential equation. Remember, an exponential equation, it has x as part of your exponent. So what we're going to be doing is the first step, you will need to isolate the base with your exponent. So that's going to be your first step. So isolate base with exponent. After that, you're going to take the log of both sides in order to get rid of that exponent. Okay, so let's go ahead and get started. So number 1, notice that the base is 3, the exponent is x plus 1. So it's already by itself. So what I'm going to do is I'm going to take the common log of both sides of our equation, because whatever we do to one side we have to do to the other. The reason we're going to take the log of both sides is so that way I can take that exponent. Remember our law of logs, we can take the exponent and make it a coefficient in front of that log. Okay, so we're trying to solve for x. So we got rid of the exponent, made it a coefficient. Now I need to get rid of this log term. So what I can do is I can divide both sides by the log of 3. So I'm left with x plus 1. And let's type these in. These are common logs, so we can use the calculator here. So log of 81 divided by log of 3. And we get 4. Okay? So then from here to solve for x, we're going to subtract 1. So x would equal 3. Now remember on your log equations, the ones that had logs, we had to check it and make sure that it didn't cause that m or n to be negative. In this case, we can have negative exponents because we know what to do to make them positive. Okay? So you could just plug it in and check it if you wanted to check it. But there's not anything that you really need to be checking for, but just to make sure that it equals that 81 up at the top. Alright, so let's take a look at the second example. So first step is to isolate the base with the exponent. Notice it's already isolated, it's already by itself. So my next step, or my first step, will be to take the log of both sides. So I'm going to take the log of 2 to the x and take the log of 5. Okay, so the reason I'm taking the log of both sides is so that way I can make that exponent a coefficient. So you should have x log of 2 equals log of 5. From here we're getting x by itself, so we're going to divide both sides by log of 2. So from here I'm using the calculator, so I'm going to do log of 5 divided by log of 2. We get a decimal, let's round to 3 decimal places, 2.322. You could check it, plug it back in, it would be 2 to that power gives you 5. So you can check it. Okay, so looking at 3, remember the first step is to isolate the base with the exponent. The base with the exponent is this 3 to the x there. So we need to get rid of the 8 starting out. So divide both sides by 8. Let's go ahead and leave it as 5 over 8 there. Okay, so now we have the base by itself with the exponent. So now I'm going to take the log of both sides. I'm going to go ahead and skip the step and go ahead and write the x in front of the log of 3. Because that's the reason why I'm taking the log of both sides, is so that way I can get rid of that exponent and make it a coefficient. So from here, to get x by itself, divide by log of 3. So plugging that in. I have log of 5 divided by 8 divided by log of 3. We should get negative 0.428 when we round it. Again, you can plug it back in and check it. Alright, let's go ahead and go to 5 and then we'll come back to 4. Okay, so 5, we want to isolate the base with the exponent. The base is e, the exponent is 0.3 to the x. We have to isolate it, so the first step is going to be divide by 500. I'm going to reduce 600 over 500 to 6/5. Okay, so from here, we took the log of both sides in all the other examples, but notice that we have an e in our equation. If we have an e in our equation, we're not going to take the common log of both sides. We're going to take the natural log of both sides. So if there is an e in your equation, you should be taking the natural log of both sides in order to make that exponent a coefficient. So now in front, I'm going to have 0.3x natural log of e equals natural log of 6 over 5. From here, I'm wanting to get x by itself. You can do it all in one step or 2 separate steps. Divide by the natural log of e, then divide by 0.3, or you can do it all at once. Divide it by the 0.3 natural log of e. If you're doing it all at once, you must put parentheses around your denominator. So I have, make sure you're doing natural log. The natural log button is to the left of 4. So natural log of 6 divided by 5 divided by, again, you have to put parentheses if you have a coefficient in front of your log. So parentheses 0.3 natural log of e, so second, divide, and you should get 0.608. So again, if you have an e in your equation, in order to get rid of that exponent, you need to take the natural log of both sides and not the common log. Okay, so let's go back to number 4. Now, if you look at number 4, notice we have 2 different bases with 2 different exponents. So this one's going to be a little more difficult, okay? Alright, so isolate the base with the exponent. Notice both of them are by themselves. So I'm going to take the log of both sides, just the common log, because I don't have an e. And the reason I'm taking the log of both sides is so that way I can bring that exponent in front and make it a coefficient. So x minus 2 log of 5, and then 3x plus 2 log of 3. If you have exponents on both sides with variables on both sides, what I want you to do from here is distribute the logs to both of the terms in front. So you're going to have x log of 5 minus 2 log of 5 equals 3x log of 3 plus 2 log of 3. Alright, so if we have 2 different variables, we want to move the logs all to one side, or your x's all to one side. and then move everything else to the other side. So notice I have an x here, and I have an x on the other side. So I want those two to be on the same side, everything else on the other side. So I'm going to add 2 log of 5. And I'm going to subtract 3x log of 3. Okay, so I'm going to have x log of 5 minus 3x log of 3 equals, those cancel, so I'm left with 2 log of 3 plus 2 log of 5. Okay, so we move the x's to one side. So what I want you to do is I want you to factor out the x on the left side of your equation. So you're going to have x on the outside. We're taking an x out of both of those terms, so I'm left with log of 5 minus 3 log of 3. And I'm just going to rewrite everything else. We'll go one step at a time. Alright, so now what I want to do is I want to condense both of those logs into one. So I need to make that coefficient an exponent. So that would be 3 cubed, which would be 27. So notice we're subtracting. So when we subtract, we condense by dividing. So 5 divided by 27. Now looking at the right side, I'm going to make those coefficients exponents. So I have 3 squared, which would be 9, 5 squared, which would be 25. So what I want to do to condense those two, since I'm adding, I need to multiply. So you're doing 9 times 25, that should give you 225. From here, we're wanting to get x by itself, so now I can divide by log of 5 over 27. So plugging into the calculator, you're going to have log of 225 divided by log of 5 divided by 27. So you should get negative 3.212 for your answer. So if you have two different bases, one on one side, one on the other, two different exponents, then with variables on both sides, you need to take the log of both sides, then distribute and move all the x's to one side, everything else to the other. Once you have it in that form, you can factor out the x that they have in common, and then you can condense the logs on both sides in order to get one log on the left, one log on the right. Okay, so the reason why we are using logs when we're solving exponential equations is to get rid of that exponent, because that's where our variable is on an exponential, and make it a coefficient, and then you're able to solve for that variable. If you have any questions, make sure that you're coming in to ask any questions that you have before school or during action.